Good morning, neighbors. Pollution. Pollution's a very huge word. It's like saying science, because you need the sciences to understand pollution. And the sciences of understanding risks and hazards. Instantaneous ones, things that could happen right now, or things that could happen in the future, cause and effect type of issues. So, when I moved over here to the Northwest, I began researching more about the Hanford site. I'd known of it for decades. It's just a part of natural history now, because humans are a part of nature, right? That's a fact. It's taken us about 400,000 years of being human to get this far and have a glass window in our doors, right? So, one of the things in looking at Hanford, trying to understand how radioactive things can travel, is a well-studied, it's a part of chemistry, kind of called stereochemistry, how things move and migrate. Professor Dave just did a thing on titrations, how titrations work. So what does that got to do with what I'm talking about? Well, for the Hanford site, there was a company in charge, an institution in charge of managing all of the wealth of information that came out of the research from Hanford. It's distributed across a number of universities and research facilities and institutions that actually maintain those records, because they are scientific data, information we have learned about how pollution travels in the soil. In this case, the pollution is a type of radioactive element. So, inside this massive amount of studying, reading, trying to understand what was published under the Battelle Institute's guidance, which led me to a university in Utah, which is one of the repositories for this information. Another one's, there's quite a few of them linked together, and still are. So anyway, what they had found was radioactive materials deposited from the wind, from releases from the Hanford site, were deposited across certain areas of the region in high enough amounts to be measured. So their question was, once this is on the ground, how is it going to move? And pertaining to that, there were studies on how the radioactive materials leached, titrated, soaked down into the earth below, which means they could migrate elsewhere, like into an aquifer. Now, they had these ideas and these theories because they had already proven it by using radioactive waste generated from our nuclear research that had migrated into the nation's aquifers, right? The aquifers we pump water from. How much? We're talking parts per million, parts per billion of elements that simply shouldn't be there. But they are, and we learned about them through research done by Exxon Production Research in Houston, Texas, in unison, in partnership with the USGS and a number of other big institutions. This word has to work. So, that soil migration study, I read that about 10 years ago, 12, 14 years ago now. It's archived somewhere in a huge directory that... So, that paper identified the migration of radioactive elements down into the soils in Hanford. Just one study, one question science had about how materials travel in this world, the real world, this universe that we're in. Well, that same study was done for Fukushima's fallout, because there are maps of the distribution of the radioactive elements and the heavy metals released from that tragedy. And what they found was, and they compared it to other studies, was the materials were migrating 3 times further through the soils in Japan than they were in the soils in the Hanford region. It's a southeast portion of Washington. It's high desert, beautiful country, some good people, worth a visit. There's lots to see there. You can get a tour of the Hanford site and reservation and see its awesomeness and barely see its issues. Buried in tank farms, leaching out into the aquifer, into that plane of existence, that alternate universe few people understand. So what that showed was these materials migrate, titrate, move through the soils at different rates depending on the soil composition. One of the facts in this is these materials can accumulate. They can gather at the bottom of a puddle. They get washed out by rain. So they soak and leach down into the soils. This has to do with those tons, the thousands, tens of thousands of bags of waste scooped up of topsoil containing radioactive elements that cause harm. It's more than a risk, or they would not have put those bags where they did. They would not have spent millions and billions, close to $1 trillion on that cleanup so far, because that's how it really works. So who protects us from these risks? Good question. These big things have to work. Pieces out, lots of pieces.